So a student asked me during one of my live streams in one semester, is it okay to pick any carbon in the two-dimensional stereoprojection as your number one carbon? And it was a great discussion because actually you can't, and it's kind of subtle while you can't. So let's start with our 2D projection here. And this 2D projection comes from taking a light and kind of projecting the light through the cyclohexane ring. So this ring here, and looking at the shadow you produce. So if we look at a cyclohexane ring in the boat conformation, there are 3 axial positions. That point up. So if I build my cyclohexane molecule, I've got 3 cyclohexane positions that point up. And so if I look at it through the ring itself, I can turn it 120 degrees and never be able to tell the difference. And so when it comes to which one is the number one carbon, this and this cannot be treated equivalently because one of them is going to have an axial atom up, the other is going to have an axial atom down. And so if we draw the axial positions, this is what we get. So which ones can you define as carbon number one? Well, traditionally we want to do the one with the axial up. And this is just to make it easier in terms of going back and forth between the 2D stereoscopic drawing and the line bond drawing. So any of these 3 axials can be treated as the number one carbon because it points up. That's traditionally what we think of when we draw these flat 2D rings, is that the top one pops up and the bottom one pops down. Now, if you define this as your starting carbon, it's actually going to require you to take the ring and flip it 180 degrees. And so you would actually end up having to work the opposite direction. So when we start numbering here, we're going to start numbering, if we were looking down at the ring, clockwise. But if you start as this is the number one, then you'd actually have to go the reverse way. You have to do the counterclockwise. So when taking your 2D stereo projections and converting them into the line bond drawings, there are 3 carbons you can pick as your number one carbon, the top carbon in the drawing, simply because of how we translate this 2D drawing, this stereo line bond drawing to the stereo drawing. Either this one, or this one. Now, the relative positions have to be correct. So if you define this as 1, we're going to work around the ring clockwise. So clockwise here is 1, 2, 3, 4, 5, 6. Or if you start here, 1, 2, 3, 4, 5, 6. Or if you start here, 1, 2, 3, 4, 5, 6. If you decide to define this is your number one carbon, or this is your number one, or this is your number one, you're actually going to have to work counterclockwise around the ring in order to get the correct answer when you're done. So 2, 3, 4, 5, and 6. So you would number it 1, 2, 3, 4. You'd number it 1, 2, 3, 4, or 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And again, this comes about because we typically define, when we convert this drawing to this drawing, what we're going to do is pop that out and push those down. And because we've defined it that way, in order for you to get things in the correct axial equatorial positions, this or this have to be your number one carbons, and you have to work clockwise around the ring. If you choose to define these kind of downward pointing angles as your number one carbons, you can do that, but now you have to work around the ring counterclockwise in order to get the correct answer. So kind of a little bit of a nuance. It's a lot of symmetry arguments. You can kind of see this if you build your 2 cyclohexane rings, create the stereo projection, and then see what happens when you number them backwards and when you change things around. But this is the conclusion that you're going to end up drawing. And again, it kind of all boils back to the beginning when I talked about this 120 degree symmetry. If we rotate this ring 120 degrees, we're back to this position or this position. So this carbon is equivalent to every other carbon around the ring, and vice versa. These 3 are equivalent because they represent every other carbon around the ring.